Let's make some glitchy emission shaders in Blender, quick and easy. In a new project, delete everything and add a plane. Rotate it 90 degrees and scale it up on the x-axis by 1.6 and on the z-axis by 0.9 to give us the 16:9 aspect ratio. Now make a new material for it, remove the principal BSDF, add an emission and connect it to the output. Plug in any image texture to the color of the emission node. You can increase the strength, but that gives us a boring looking emission material. So let's add some stuff to it. Add a new wave texture and a mix color before the emission color. Plug in the wave texture to the B socket. Change the axis to Y and the mix mode to multiply. That already gives us some nice scan lines. You can change the scale of the wave texture. Add another mix color after the first mix and plug in a noise texture. You can change the mix mode to multiply, and you can also add in a color ramp if you want to adjust the contrast of the noise texture. Add a mapping node and change it to UV if you wish to map the texture on the plane. Now adjust the scale, detail, distortion, etc. in the noise texture according to the look that you want. You can also move the color ramp sliders around. If you have the node wrangler enabled, just Ctrl, Shift and click on any node to preview just that node. And then click back on the emission shader so that you can see the full effect. We can see some good scan lines and noise effect on the image, but you can adjust the detail, distortion, etc. in the wave texture according to the look that you want. You can pause and copy my settings if you wish to recreate my texture exactly. I also added a color ramp to further adjust the contrast of the wave texture. Once you're happy with the textures, it's time to animate them. Select any node and press Ctrl T to add a mapping node. Now we'll move the texture on the y-axis to create a scanline effect. Now you could keyframe this value, but I just added a driver by typing #frame divided by any number. The smaller the number is, the faster the animation, and the other way around. For the noise texture, I changed the noise type to 4D and added another frame animation over there using the driver. And that gives us this noisy emission shader with scan lines. For taking it one step further, add a keyframe in the beginning and the end of the animation in your emission shader. Then shift to the graph editor, rename your material if you have not added a name, and then add a noise modifier and increase the strength to vary the strength randomly. That gives us this glitchy emission shader, which looks way better than a static plain emission shader. You can replace the image with any video, unwrap it properly, and then set the keyframe range to have a moving video on your glitchy emission shader. This is a very lightweight effect that works great in both EV and cycles. Let's make our second emission shader now. This will have some dead pixels effect. The basic setup is the same. Remove the principal BSDF, connect an image texture or a video to the emission node and plug it into the shader output. For a video texture, set the frame range and check cyclic and auto refresh so that it plays in your viewport. Now let's make a mask for the dead pixels effect. Add a Voronoi texture and plug it into a color ramp. Ctrl Shift and click on the color ramp to preview it. Change the type to Chevy Chev and now adjust the color ramp. The black parts are where our image will come through and the white parts are where we'll get the dead pixels effect. So you can adjust the scale, detail, etc. according to the look that you want. Keep the black parts maximum so that we get most of the image coming through the mask. Now we need to make the dead pixels. So I added another color ramp, set the mode to constant and added some more sliders to make an RGB separation in the color ramp. This is completely optional. As you will see ahead, I have used a black and white mask which gives us a similar dead pixels effect. The colors can be altered according to your liking. Now add another Voronoi texture with the same type or duplicate the previous texture and connect the color of it to the color ramp. When you adjust the color ramp of the mask now, you can see the dead pixels coming through the image texture. You can reduce the scale of the mask depending on how many dead pixels you want on your screen and what is the size that you require. You can move the pixels randomly across the screen by using the mapping coordinates of X or Y axis. So I added a mapping node to the Voronoi texture mask, and I'll use a driver like we did in the previous step to move the dead pixels mask on the X or Y axis. You can see I also replaced the color ramp with a black and white simple color ramp that gives us a very clean dead pixels effect. And once with the driver activated, you can see the pixels randomly shift around on the screen, which gives us a very glitchy effect. And for the final step, like we did in the previous method, you can add a noise modifier to the emission strength and also add another mix color node and mix in some wave texture for the scanlines effect along with the dead pixels. Now let's make a semi-transparent holographic glitchy emission shader. Like in the previous step, I started with the 1.6 by 0.9 plane, delete the principal BSDF, add an emission shader and set a suitable strength. You can also plug in an image texture into the emission color. UV unwrap it if required. Now add a mix shader and plug it in after the emission and mix it with a transparent BSDF. That gives us a semi-transparent look. But by itself, it's a very basic and boring effect. So I added a layer weight node, and depending on how you want the exact look, you can connect the Fresnel or the phasing to the factor of the mix shader. I connected the phasing to the factor of the mix, and that gives us an effect in which the shader is bright when viewed head on and it's slightly transparent on the sides. I also used the first texture that we made to copy the scanlines and noise texture and mix it in before the emission. You can add another driver to animate the scanline effect, and that gives us a semi-transparent holographic glitchy emission shader, which looks the brightest when viewed head on and fades off into the sides on angles. And you can adjust the blend weight of the layer weight node to control this effect. Like the previous two textures, I also added a noise modifier to the emission strength. Not just that, you can add this holographic texture to random objects as well, like a Suzanne monkey head or even a cube. Just make sure to UV unwrap it, and you can have semi-transparent holographic glitchy shaders applied to any model that you want. So this is how I created these three glitchy emission shaders, which I think would look great in cyberpunk or futuristic city scenes. They work great in both EV and cycles, so try them out and let me know. And follow me for more videos coming soon.